Namaste, welcome to Pythagoras Academy. This is Vikram Dachepally. If you have a system in equilibrium which has got certain springs and strings and pulleys, and if you cut one of the springs or strings, what happens at that instant? So this model, this is the case where we are trying to find the acceleration of different parts of the system. That too, immediately after cutting a spring or a string, that too when the system is in equilibrium. So condition number one, the system is in equilibrium. Take this simple case, two springs are connected to this block. The system is in equilibrium. So there is some equilibrium stretch. So because both are connected in parallel, if the stretch in the spring or spring constant K is X, in the other spring also it is X. Now draw the free body diagram of this block. It has got mg down and kx and 2kx up. So 3kx is equal to mg, or x is equal to mg by 3k. This is the first step to solve these kind of questions. The system is in equilibrium. The equilibrium stretch in each spring is mg by 3k. Now case 1. The first spring, so I'll call the spring constant K spring as first spring and the other one as second spring. So if I cut this first spring, so if you're cutting this, then what is the acceleration of the block right after, just after cutting the spring? At that time t is equal to 0.000000001 seconds, just after cutting the spring. So the fundamental concept here is that if you cut a spring or string or any part of the system, the tension is immediately affected, but the other springs are not immediately affected because the stretch does not change immediately. As long as the stretch or the compression remains as it is, the spring force remains as it is. Now as you cut the spring force of this spring becomes 0. Now if you draw the free body diagram of this M, so it is mg and this kx has become 0, but this 2kx has remained as it is. But now mg is equal to 3kx, more than 2kx, so the block would accelerate down. So immediate acceleration of the block I can get by applying Newton's laws, mg minus 2kx, that is equal to m into a. So mg is equal to 3kx here, so 3 or I can write mg minus 2 times of kx is mg by 3, which is equal to m into a. So m is gone, g minus 2g by 3, that is g by 3, which is equal to a. We can similarly do case 2. So case 2 is 2k spring is cut, the second spring is cut. What is the immediate acceleration of the block? In that case, follow the same steps. The free body diagram, mg, 2k spring is cut, so the spring force becomes 0 in that 2k spring. So there is only kx acting upwards. Definitely the block would accelerate down because mg is equal to 3kx in magnitude. X did not change. So kx will be equal to mg by 3. So this is the case where mg is acting down and mg by 3 is up. So the equation would be mg minus mg by 3, which is equal to m into a. So a is equal to 2g by 3 downwards. Next instant, everything changes. Next instant, because of this acceleration, the block would start coming down. As the block comes down, the stretch in the spring will change, the stretch in the uncut spring will change, the spring force will change, acceleration will change, everything changes. That is a different story altogether. But immediately after you cut the spring, this is what happens. The acceleration of the block in the first case is g by 3, in the second case it is 2g by 3. Let us take another example here. So let us say I am cutting the string. So on the left side the total mass is 2m, on the right side is m plus m, it is 2m. So the system is in equilibrium, that is the first condition. The system should be in equilibrium. Now I am cutting a part of the system. what is happening to the other parts of the system. Now, once you cut the string, then so before cutting, let us first find, before even cutting this string, let us first analyze the equilibrium situation. So in equilibrium, so you have 2mg down, and it has got tension T up, and we have mg down, kx down, and tension T up, and we have m again, then mg down and kx up. So in equilibrium, net force is 0, so kx is equal to mg. Now T is equal to kx plus mg. So kx is equal to mg, so T is equal to 2 times of mg. And now here T is equal to 2mg, we get a redundant equation. So T is equal to 2mg even from the first free body diagram. Now at this equilibrium situation, if you are cutting the string, as I said, if the string is cut, so there is only one string. Even if there are other strings, one part of the system is disturbed, then the tension is immediately changed. So anyhow, there is only one string and you are cutting this string, the tension becomes 0. So analyze the mass 2m now, it has got 2mg and tension becomes 0. So there is no force in that direction. So let me call the acceleration as a1. So the net force is 2mg, that is equal to 2m, mass is 2m into a1. So a1 is equal to g downwards. So as soon as you cut this string, 2m is experiencing free fall at that instant. I'm only bothered about that instant. Next instant, based on different aspects, we can decide what is happening to the system. But at that instant, acceleration of 2m is g down. Now consider the other block m. So if you consider this m, let me move this to this side. All right. So it has got mg down and kx, which is equal to, so kx is equal to mg. So this, it remains as it is because the stretch hasn't immediately affected. The stretch remains same at that instant. T is equal to 0.0001 second, the stretch remains same. Next instant, obviously because the block is accelerating, the stretch will change, the spring force will change, the acceleration of different blocks will change. Now, so, and what about the tension T up? So this is 0. Now it has got acceleration a2 down. So net force in the downward direction is 2mg, mg plus mg 2mg. That is equal to mass into acceleration a2. So a2 is equal to 2g down. Now coming to the third case, third block, it has got mg down and kx, which still remained equal to mg because there is nobody to disturb this kx at that instant. So net acceleration a3 of this is 0. It is at momentary rest only. So as soon as you cut this string, the block that is completely unaffected is this third block m. So the final answer is this is g down and this is 2g down, and acceleration of this block is 0. So this is how we work with this kind of problems. And what happens instead of cutting the string? What happens if you cut the spring? You can try by yourself and you can post your answers in the comment section. What happens if you cut the spring instead of cutting the string? Find the acceleration of 2m, m and m at that instant just after cutting the spring. So I'll be waiting for your answers. If you have any questions or queries or suggestions, you can always use the comment section to interact with me. I'll be more than happy to respond and receive your feedback. This is Vikram Dachepally signing off. Namaste.